multiplication, for example, if you're given a task consists of a sequence of choices in which there are P selections for the first choice, Q selections for the second choice, and R selections for the third choice, and so on, then the task of making these selections can be a multiplication. The number of the first one multiplied by the number of second one, P times Q times R. So there are P times Q times R different ways of making decisions to select. Suppose a task has the first one has 6, and another one has 5, and another one has 4, and you want to select. The question is find the number of ways, different ways of selecting. It's called multiplication rule in counting principles. You have to multiply the different ways, 6 times 5 times 4, where 6 is Q and 5 is 6 is Q, 5 is Q, and R is 4. Okay, so this is just an example. Well, so let's do an example in eraser. This is an eraser. Okay. All right, so an example, counting the number of possible meals. Counting the number of possible meals. Okay, the fixed dinner at a restaurant provides the following: an appetizer. There are 2 appetizers. There are how many entries? 1, 2, 3, 4 entries. And there are 2 desserts. Appetizer 2, entries 4, and a dessert 2. And the question is asking you, how many different meals can you order? How many different meals? So what you're going to do is multiply them up. You can also be told to use, and so this is going to give you 4 times 4, 16. There are 16 different ways you can order. Okay, so those that restaurant is they have 16 different orders, so you can choose one. You can't eat all of them. You can't choose all of them. You have to choose one. Suppose you're told to draw a tree diagram. You could be told to draw a tree diagram for this. Okay, for appetizer, let me just say that appetizer is A1, A2. So A1, A2. That's appetizer. And then entries, there are 4 of them. So we're going to call them E1, E2, E3, because if we're told to draw a tree diagram for this, E3, E4. And each branch has okay, E1, E2, E3, E4, and the dessert, there are 2 kinds of dessert: cream, ice cream, and cheesecake. So you have 1, 2 right there, 1, 2. So you have C1, C2, C1, C2. I can call this one C1, C2, C1, C2, C1, C2, C1, C2, C1, C2, C1, C2, C1, C2. So you could be told to draw a tree diagram to show the number of number of orders that are available you can choose from. So actually there are 16 different orders. When you count the last branch, you have 16 of them. You count the last branch. Another way of finding, suppose they give you a tree diagram, count the last branch. Otherwise, you can multiply them 4 times 2 times 2. So when you count this last branch, you have that the sample space. Sample space is 16. The number of orders is 16, not 66. The number of orders, that says how many different meals. So that's what. Okay, so let's go to the next one is factorial. If n is greater than 0, it's an integer. The factorial symbol n factorial is defined by that. Okay, so how do I recognize the factorial symbol? So if factorial symbol looks like an exclamation mark. Looks like an exclamation mark. So suppose I am told to find 3 factorial. So that is 3 exclamation mark, which is the same as 3 times 2 times 1. 5 factorial is the same as in a calculator and evaluate them. What is 0 factorial? What is 1 factorial? What is so we want to calculate them so that we know how to calculate, do it with our calculator. So okay, so what I'm going to pull up my calculator. So we want to know how to use factorial. How do I calculate factorial in my calculator? All right, so the first one is 3 factorial. You type in 3, then go to math, arrow to PRB, choose factorial. Number 4 is factorial. We already found that 3 factorial is 6, but it doesn't know how to check with our calculator. Therefore, I can find factorial by hand, algebraically, and I can find it using my calculator. You must be able to find it using both of them. And the next one is 5 factorial. And I go to math, arrow to PRB, number 4, and this. So 5 factorial is 120. You multiply here, you can find 120 also. 5 times 4 is 20 times 3 is 60. 60 times 2 is 120. Therefore, 5 factorial is, so you can find factorial using your calculator. That is what I'm trying to emphasize. Okay. In the calculator, go to, okay, we have already talked about that, so we can. The next thing is permutation. Another counting principle is permutation. So we already said multiplication is one of them. Factorial is one of them. Another one is permutation. Permutation, it can be written as this. Suppose I have n objects, n permutation r objects. That's a formula n factorial over n minus r factorial. Okay, n factorial over n minus r factorial. All right, so suppose I have 5 permutation 2 it is 5 factorial all over 5 minus 2 factorial. And that is, you multiply out, you have 5 times 4, 5 times 4 times 3 times 2 times 1, all divided by 5 minus 3 minus 2 is 3, 3 factorial. So 3 factorial will cancel everything here so that 5 permutation 2 is going to give us 20. Okay, so suppose I'm told to use my calculator to find permutation 5, permutation 3. I can check with my calculator. So I'm going to check with my calculator. Is 5 permutation 2 20? That's what I'm asking my calculator. So I will go to math, to put in 5, go to math, arrow to PRB. Permutation is number 2. If I put 2 there, I hit enter, it's 20. So you can verify your answer with calculator. So it's always good to verify your answer with calculator. So 5 permutation 2 is 20. Okay. All right. So that is permutation, but let's make sure we know the properties of permutation. Property number 1, there must be n distinct objects. N distinct objects. Repetition of objects is not allowed. Order is important. So let me get an example so that, let's get an example. Okay, so let's get an example. I'm told that the object must be different. So I'm going to choose 3 letters. 3 letters A, B, C. So we can A, B, C are 3 letters. So number 1 is saying there have to be n distinct objects. They cannot be, none can repeat. In other words, I'm not allowed to have A, B, C. No. So this is not that. Repetition of objects is not allowed. They have to be distinct. Order is important. So in permutation, order is important. We have to be careful with that. Whenever I'm told to find the permutation of ABC, where order is important, in other words, how many ways can I arrange this when order is important? So I have A, B, C, and then I can have A, C, B, I can have C, B, A, I can have B, A, C, B, A, C, I can have I can keep on working, but let's see how many of them can I actually have. 3 factorial, so 3 times 2 times 1. Actually, there are 6 different ways I can arrange. I can arrange those ABC in factorial because order is important. Because order is important. Okay, remember that order is important is not the same as repetition. There is no repetition. Order is important means that this is a different permutation, this is different, this is different, this is different. Okay, so there is no repetition of an object cannot repeat. Okay, so the next one is, we already put it in calculator. Okay, the next one we want to talk about is combination. So what is combination? All right, the formula for combination is on the right. And combination R is the same thing as, I'm going to rewrite this. And combination R, since like I have n things and I want to choose R at a time, repetition is not allowed, order is not important. So then I have to rewrite the formula, n factorial over R factorial into n minus R all factorial. Okay, so that is the formula for factorial, and R is always going to be smaller or equal to n. R cannot be greater than something like, I cannot choose 11 things out of 10. Doesn't make sense. If I only have 10 shoes, then I cannot choose 11 out of 10. So if it is not there, it's greater. R cannot be greater than R cannot be greater than n. Okay, so let's look at the properties of combination. We want to know what is the difference between combination and permutation. What is the difference between combination and permutation? What is the difference between combination and permutation? Okay, for number one, there are n distinct objects. In other words, no repetition. No object can repeat, like A, B, C. They're all distinct. No object can repeat. Repetition of objects is not allowed, almost the same thing. Order is not important, very, very important. See, this is the difference between combination and permutation. Order is not important. Order is not important. So if I'm told to find the number of ways I can arrange ABC, ABC is still going to be ABC. ABC and CAB are the same because order is not important. In combination, order is not important. All right, suppose I am given suppose I am given 6 combination 2. I can do it by hand. 6 times 5 times 4, 3, 2, 1, and then 2 factorial right here, multiplied by 6 minus 2, which is 4 factorial. I can just put 1 this. I know that 4 factorial can cancel from here, and 2 going to 6 is 3. Therefore, 6 combination 2 is 3 times 5, 15. So I'm going to use my calculator to verify my answer. So is 6 combination 2, 15. Let me use my calculator. Okay, so the first thing I want to do is turn my calculator on, clear. Type in the number sample size, so that's 6. Go to math, arrow to PRB. Combination is number 3. and 2, you hit enter, that is 15. So 6 combination 2 is 15. 6 combination 2 is 15. Okay. All right, so we can calculate combination and permutation from our calculator. That's the most important thing. We can calculate combination and permutation from our calculator. How many different simple random samples of size 4 can be obtained from a population whose size is 20? Okay, the 20 individuals in the population are distinct. So they are human beings. In addition, the order in which individuals are selected is unimportant. The order is unimportant. Thus, the number of simple random samples of size 4 from population of size 20 is a combination because order is not important. Okay, so now we know it's a combination, and all we have to do is type in 20 combination 4 in our calculator and get the answer. Okay, well, let's go to non-distinct objects. Permutations with non-distinct objects. For example, we're going to get a word, school. Let me use school. The word school, if I'm told to write school in so many different ways, in how many ways can I write school? So first of all, I will count how many letters are in school. 1, 2, 3, 4, 5, 6. So this is why it's called non-distinct objects. There is a repetition there. So see how we deal with the repetition. 6 factorial, the number of letters in school, over, you count the number of repetitions of any number, 2 factorial. If any number repeats, count the number of repetitions and divide by that repetition. Okay, so 6 factorial divided by 2 factorial, that's what we have. And you can use calculator or by hand to simplify this. You can simplify it by hand or by calculator. So, so I go to math. I don't even have to use math, but anyway, I can go to math, or first of all, type in 6 factorial. So 6, go to math, get factorial. Factorial is number 4, and divided by parentheses. Whenever factorial is in the denominator, you really want to get parentheses. 2 factorial, go to math, arrow to PRB, get factorial, and close parentheses. And when I hit enter, my answer is there are 360 different ways I can arrange the word school, non-distinct objects. There are 360 ways I can arrange the word school. Okay. Okay, so this is 5. And then the lottery, we can do that later on. Can come back to lottery. So the next one is 5.7. Next one is 5.7. Section 5.7. So we get the note 5.7. And after that, we start reviewing. Okay, putting it together. Which method do we use? We're putting it together. This is probability. Which one do we use? Learning objectives for 5.7. Determine the appropriate probability rule. There are so many rules to use. Determine which one that you have to use. So I'm just going to bring this down. We look at it and find out which one do we actually use. I'm going to make it a bit smaller, a little bit smaller. Okay. This Venn diagram is very important. This Venn diagram is very important. It says, are you finding the probability of a single event? Are you finding the probability of a single event? If it's a single event, if you say yes, the outcomes equally likely, and you say yes, then you can use the probability of n over s. Okay, you use, well, that relative frequency. Okay. Okay, the next one is you look at the next one. If it's not a single event, do the events involve or an and, or at least if it's an or probability, then are the events disjoint or mutually exclusive? Remember, we talked about them. If they are disjoint, then it's all probability, and you use and. You use the property of and. Okay, if the events are non-mutually exclusive, which means there's joint probability, then you use the general rule. Okay, so you use the general rule if you have a Venn diagram that is joint, there is a joint, then you use general rule. If you have a Venn diagram that has a disjoint when the ovals are not touching each other, okay, you use or probability, addition probability. Okay, now if the probabilities are, it's not a single event, do the events have or? And if it has an and, you multiply. Suppose it is and, you multiply and independent. So and independent. But if it's and it is not independent, then it can be conditional probability. You use the formula for conditional probability, which we talked about. All right. Also, we talked about multiplication rule. Whenever you have and, it's a multiplication. So you have to multiply. If it is a general rule of you have to use the general rule, it means there's a joint probability that they can happen at the same time. They are not mutually exclusive. They can happen at the same time. If it's an at least probability complement rule, if it's an at least probability complement rule, okay, so okay, so I think I'm going to leave the remaining for you to. So we'll quickly go to the practice test. So let's go to the practice test, and there we can work on probabilities. We are working on probabilities today because we're not actually reviewing. We will start next week to review. Our review starts next week. All right, so guess question number one. Is it a probability question? Let me check. Is question number one a probability question? Yes. Okay, since it's a probability question, that's what we are doing. So it says, suppose that E and F are two events. So there is not a single event. Okay, and we are given that the probability of E and F. So we are given a combined probability of E and F, and we can write intersection wherever I see and is equal to, let's see what is given to us, is 0.1, and we're given that the probability of E is 0.5. Probability of E is 0.5. And we are told to find the probability of F, given that E has happened. So find the probability of F, given that E happened first. So I hope you know how to say this. You should be able to say it. Find the probability of F. Okay, I need to make you bigger. Given that E happened first. So when you are given that question, what it means. Find the probability of F. So the first thing you want to do when you are given this question, find the probability of F, given that E happened first. You first of all write the numerator. The numerator, which is probability of E intersection F, all divided by, this is the formula. Write the formula, make sure you write the formula. And then substitute in the formula, they gave you everything. The probability of E and F is 0.1. The probability of E is 0.5. Find the probability of F given that E happened first. That is 1 out of 5. So you could be told to leave the probability in fraction, in decimal or percent. That's 0.2. And you could be told to leave the probability in percent, that is 20%. So the probability of F happening, given that E has happened, is 20%. Okay, number 3 is another question in chapter 5. This question in chapter 5 says, find 9 combination 7. So we already talked about combination right now. Find 9 combination 7. So I can do it by hand, especially if I'm told to do it by hand. If I'm told to do it by hand, I have to do it by hand. All right, so 5, we are told to find the probability of, let's see, 9 combination 7. So 9 combination 7. First of all, I'll write the formula. N is equal to 9. R is equal to 7. Permutation. N combination R, or 9 combination R, which is 7, is 9 factorial over 7 factorial into 9 minus 7 factorial. Okay, and by the way, By the way, remember that the formula for combination n combination r is n factorial all over r factorial into n minus r factorial. Okay, one thing you need to actually observe is that this quantity is permutation. So whenever you're given a combination question, if you know the permutation, you just have to divide by the r. So n combination r is equal to n permutation r divided by r. So that is by the way. And I'll get an answer. So I have to simplify the numerator. 9 times 8, 7, 6, 5, 4, 3, 2, 1, all over 7 factorial into 9 minus 7 is 2, the 2 factorial. And then I can simplify it. By the way, 7 factorial will cancel everything here. And 2 factorial, 2 going to 8 is 4. 9 times 4 is equal to 36. 934 is 36. Okay. So my answer is 36. Let me verify my answer with my calculator. So I have 9 combination 7. Good. 9. Go to math. Arrow to PRB. Combination is number 3. 9 combination 7. Hit an answer. That is 36. 9 combination 7 is 36. Okay. 9 combination is 36. Okay, so this is so we're going to start continue with